right, review number 1 here. Design an experiment with a control and experiment group. Identify which is the control, which is the experiment group. Okay, I'm going to give a test. Have, get a review, and have, do not. Half that gets a review. Experimental group. Control group, half that do not. You can do this for testing, you can do this for a new product, you can do this for anything, but you have to come up with something. So just think about it for a minute. I'm going to give a survey to high school students about how I'm doing as a teacher. I plan on only giving the survey to students who have A's. Is this appropriate? How would you describe my technique? Is this appropriate? No. It is biased. How would you describe your technique? Well, I need to survey students of all grades, not just A's. I'm trying to make myself look good here, so I got to be cautious of something like that. Okay, 2 letters are selected at random from the word ideas. What's the probability of selecting 2 vowels? Well, let's see here. Ideas. We've got 5 letters, and I am going to be picking 2 letters. So when I'm looking at this, I say, okay, there's 5 total, and 1, 2, 3 of them are vowels. So on the first letter, I'd have a 3 out of 5 chance. 3 vowels, 5 letters. Once I get the first one, however, now there'd only be 2 left, like let's say I'm taking them out of a bag, out of 4 letters, which would be 6 out of 20, or 3/10. That's where that's coming from. And sorry about my numbering. I'm going to jump back over here and keep following along. A die is rolled. Find the probability of getting 1 or 5 or 6. Well, the probability of each of those is 1 out of 6. And remember, when I see or, it means I'm going to add. Now, I can't get 1, 5, and 6 all together, so this time there's nothing in common that I would need to subtract. So I'd go ahead and just add those up and reduce my fraction. Betty's going to make a sandwich. 4 types of bread, 5 types of meat, 3 types of cheese. How many sandwiches can she make if it's 1 bread, 1 meat, 1 cheese? Just multiply those values together, and we have a winner. Ben is going to watch a comedy, a horror film, and a foreign film. How many ways can he watch the movie Marathon? 3 movies. First one he has 1, 2, 3 picks. Second one he has 2 picks. Last one he has 1 pick. Looks like 6 ways. 2 letters are selected from the word breaks. What's the probability they're both vowels? What vowels we got here? A and E. So 2 out of 6 on my first letter. 1 out of 5 on my second if I had a vowel each time. 2 out of 30 would be 1/15. I don't know if it's showing up better on yours or not. Mine, I can barely see it here. So on 8, find the distribution of the number of tails when 2 coins are tossed. Find the probability of getting 2 tails. 2 tails. Look where the bar is at. Answer. Good. 2 dice are rolled. Probability that both will roll a 5. Each one individually has a chance of 1 out of 6. So the chances of getting both of them that way would be 1 of every 36. And again, that's theoretical. I might get something different if I actually did an experiment with it. A bag of jelly beans. 5 red, 7 green, 4 blue. So 7, 16 total. What's the probability 2 green ones are picked? Okay, without replacement. So there's 7 out of 16 my first draw. Then I eat that jelly bean. Now there's only 6 green ones left. There's only 15 total left. And I'll multiply across and reduce that down, and I'm ready there. When rolling a die, what's the probability of rolling a 5 or a number greater than 3? Well, 5 we know is 1 out of 6. A number greater than 3 would be 4, 5, or 6, which would be 3 out of 6. But is there a number greater than 3 that is 5, where we have a number in common in both? Yes, 5 is. So I have to subtract that part back out, and then I can simplify it. Okay. If a coin is tossed 4 times, what's the probability that I get 4 tails? Each one of those is separate. Which would be 1 out of 16. Now if it said a tail, it would be 1 out of 2, because each time's individual. But if getting all 4, it'd be 1 out of 16. So let's see, 13. Rhonda, Jenna, Brian, and Aaron are going to a teaching conference. The principal only wants 2 of them to present on Monday. If everyone is equally likely to present, what are the possible teams? Well, Rhonda could be with Jenna, Brian, or Aaron. And let's see, Jenna could be with Brian or Aaron. Brian would be with Aaron, so I got 6 possibilities. Okay, probability of Brian and Rhonda being a team, only one of the 6 choices. A team with Aaron, 1, 2, 3 of those. And again, the nice thing about video is you can pause me if I get going too fast here. Probability of a team without Brian, there's 1, there's 2, there's 3, and about 1/2. But notice how quickly, if I have a feeling for what I'm doing, how quickly I can burn through these guys. 14. Couples plan on having 3 children. What's the probability that all 3 are girls? Oh dear. So let's see. Each time, the probability is 1 out of 2, boy or girl. So no, you do not have to draw a chart. You can just write it out through a probability of each. Our odds that we just talked about recently. If the probability of an event happening is 6 out of 11, happens total. When we do odds, we need to know how many don't happen. So how would I figure that out? I'd just minus those 2. Doesn't happen. What are the odds of the event not happening? My success would be at not happening, which would be 5, out of my non-success, which would be of it happening, which would be 6. And that's where it comes from. Math team has 8 juniors, 13 seniors. We got males and females with each here. There's 5 junior females and 6 senior females. And I can figure out the other ones just by saying if there's 8 juniors, 5 of them are female, and get those already. Probability, all ors, all pluses. Senior, how many seniors are there? 13 out of 21 total students. Females, how many females? We got 11. And how many senior females do we have? 6. 24 minus 6 is 18. And we'll get that worked out. Juniors. Probability of being a junior, 8 out of 21. Probability of being a male, there's 10 total. But junior males, we have to subtract, because again, we have that overlap. Junior males is 3. And we can kind of start to see, let's see here, divisible by 3. So we've got that one. And then finally, our probability of being a junior or senior. Now think about that for a minute. All we have are juniors and seniors. We can't have somebody that's a junior and a senior. That's kind of hard. So the probability would be 1. 17 we skipped. We're going to get rid of the Venn diagrams. We got rid of that in favor of odds. Good move. Use the chart to answer the following questions. All right, let's finish this off. Probability of male given they're overweight. So I'm only looking at the overweight crowd here. It's a male, and I work it that way. And of course, I've still got to reduce. Okay, but look at the given part first. That'll tell you the group, given that they're a female. Total number of females is 50. Normal weight, 14. and work it. Okay, but again, watch the words. Or, overweight, 66 out of 112, because it's the total number of people now. Or female, 50 of those out of 112. But how many are overweight females? Because there's my overlap that I have to subtract. Overweight females, 21 of them. And that one I don't think is going to reduce. If you have 6 CDs, how many ways can we place them on a shelf? Fundamental counting principle. As I place each one, I have one less to work with. Get my answer that way. In a class of 36 students, how many ways can I choose to get 4 on a committee? Again, I got 36 choices, then I pick one I got 35 and 34 and 33, and this number is ridiculous. Glad I don't have to figure all these out individually. Holy cow. Think how bad it is to win the lottery then. The odds of a player making a free throw are 2 to 1. Make, not make. How many total free throws? 3 total. If he shoots 27, how many will he make? Well, if he makes 2 makes for every 3 total, and he's shooting 27, 3 times what gets me to 27? Well, 9 does. So I multiply the 18. It tells me how many makes. And finally, you're building a laptop for college. You can choose from 4 screen sizes, 6 hard drive, and the case color can be one of those 3. Ooh, 3. How many distinct computers can I create? 1 screen, 1 hard drive, 1 color, and boom, we're good to go. So again, that basically covers everything. The other review will be up as well to get you some extra practice, so study hard.